Hello, my name is Sergei Chernov, and today I'd like to talk about optimizing Spring-based integration test at scale. So I work at Mira. At Mira, we do online whiteboards for collaboration. Anybody using Mira boards here? Nice, nice. We use it daily. So we could not decide which way to go, to the monolith or to microservices. So we use both. So our main application is a huge monolith with about 2 million lines of code. And also we have about 200 microservices. More than 50 teams work independently on this. And we have just thousands of integration test classes. So actually, I would like to share some insights based on our experience on two types of scale: huge monolith applications and lots of small microservices. Our technical stack is pretty classic. So the main framework is Spring Boot 3. We really love Spring Boot 3. We use JUnit 5 or TestNG, Maven or Gradle, depending on the project. Also, we use test containers for our integration tests. Just in case if you are not aware, test container is a wrapper beyond Docker environments that bootstrap and manage the life cycle of your container and allows you to map ports. So we use a lot of different databases, relational databases, cloud message queues, etc. And in our integration tests, we prefer to use real services instead of H2. So with the project growth, eventually we started observing pretty severe problems because our tests took a lot of resource. It needed a lot of memory. It took a lot of time. Tests became more flaky. They were conflicting to each other. For example, trying to use the same identifiers or ports. It became a popular excuse just not to write integration tests by some engineers, and we had to do something with it. Also, one of the negative side effects were pretty high costs to support of this test infrastructure. So we needed to find some holistic and simple solution about this. Also, our CRE team was really worried about our CI/CD environment, which was almost close to death because it tried to bootstrap too many Docker containers. So, Mira is pretty big organization and a lot of team works independently. So we, as a platform team, we were not able, for example, to review all the code. So we tried to find some scalable solution that will fit all, both microservice and our monolith application. And we try to stay on the traditional stack as much as possible. We had some initial discovery that showed us that the root problem of most of those side effects is that we have simultaneously too many active Spring contexts working at the same time. For this reason, we had a lot of heavyweight beans. For example, test containers were one of the most heavyweight beans. We had a lot of threads, and we made some initial conclusions about this. So I'd like to avoid ambiguity when we're talking about integration tests because it may depend on the company you work at. I will use the same dependency that you can find in the Spring documentation. So integration tests, tests that are defined like for you JUnit 4, JUnit 5 with runners or extensions with Spring extension. Usually they are annotated like add Spring Boot test. For TestNG, you need to extend the base class. So let's take a closer look. If you don't see more detailed, don't worry. Just take a closer look how Spring executes Spring test. In the very beginning, it analyzes, I'd like to say, some kind of static signature of our test. So, for example, it analyzes several annotations like context configuration, active profiles. Also, it goes through so-called customizers, for example, analyzing fields mock-bin, some static method with according annotations, test property source. In total, it's about 10 parameters. And with those parameters, it creates composite object, which is called merged context configuration. So what is this? It's more or less simple podio that lists string and class names of all elements that were discovered during this initial analysis. Why it makes much sense to take a closer look to this? Because this is the main criteria if test configurations are equal or not. Difference in any of those parameters mean that two Spring test classes will have different configurations. And then this merged context configuration is used for the context cache, which works pretty simple. If there is existing active Spring context, it's used for the test. Otherwise, Spring creates the new Spring context for this configuration and uses for test. And then the cycle repeats for each new test. And this cache is stored somewhere statically in the core of Spring test framework. Let's consider just a sample suite of 8 integration test classes. So I used color markers to emphasize which integration tests will use the same configuration. How will it work? So the very first test will create the context because there is no context in our cache so far. And then this context will be reused for the subsequent integration test 2. Then Spring will start executing integration test 3 that will create new separate context for this. And we will have 2 parallel contexts. So as you can see, if we have like 4 different configurations for our integration test suite, eventually at the end of working of our virtual machine, we will have 4 active Spring containers. As a shutdown hook, Spring will close all of them. But this can be too late. And too late, what I mean, at this moment we can already have a lot of problems. For example, it will consume a lot of memory, our ports are conflicting, and others. So it will consume much more memory than it actually needs. So also there is one crucial factor that you should pay attention to. Depending on your the complexity of your integration test configuration, the initialization time takes more than 90% of test execution. The subsequent tests usually are better in this relation of those time to initialize the context, initialize the test. But if it's like 50-50, it's still a considerable percent. So actually, if you run your test suite with default settings, each time when you see the Spring banner in your log means that the new context is created. So you can more or less estimate how many contexts is created during the test suite. So we can already have some intermediate conclusions and what's on agenda of today's talk. We need to somehow reduce or even minimize the number of active Spring contexts. To do this, we need to reduce the number of unique configurations. In many cases, it's like not possible because engineers, for example, want to make their own configuration. So in this case, we need to find out how to reduce the overhead of each new created context. And the last thing that I would like to talk about today is let's revisit standard behavior of the Spring test framework because it's great, flexible, and works for most of projects, but doesn't scale infinite. So we need to do something with it. Let's go with optimizations. I believe many of you who discovered this problem is familiar with a wonderful annotation which is called dirty's context. I think Stack Overflow will suggest it one of the first. And one of the most radical scenario is to add this annotation on your parent integration test class. And in many cases, it solves the problem. So how it works? After each integration test class, it will just shut down the context, and each subsequent integration test class will recreate it from scratch. So as you can see, for our test suite, it will be recreated again and again. So the problem here is that we solve one problem, but create another problem. Our test suite will take much longer than it could theoretically do. There is more elegant solution for this. So I already mentioned the context cache, which has default size of 32, and we can reduce it. For example, to use a smaller value, 4 or maybe even 1. So to do this, you need to specify the property in the Spring properties available the class path of your test. Or you can specify it in the arc line of your Surefire failsafe plugins, and there is a similar configuration for Gradle. So let's consider an example if we have cache size of 1. So you can compare like global dirty's context versus this one. So you can see that it's already better. It will be already a bit faster, because if you have subsequent tests using the same configuration, it will reuse the same context. And then when the next different configuration will start, it will close existing context, because the cache size has a limit of 1 active Spring context. So the second optimization is one of the most classic advices for this. To reduce the chance that any of your integration test configuration has non-unique, different configuration, extract as much as possible to the parent integration test class and reuse it in all subclasses. I mean that your subclasses should not, if possible, specify any kind of customizations. This way you will be able to reuse your Spring context as much as possible. If you're using GUnit 5 instead of declaring base integration test class parent, this can be a meta-transitive annotation, which can be more convenient in your case. Another optimization is related to using the mock bin. So the mock bin is a convenient way to override the bin definition in your configuration with a higher priority, and it's very convenient. Just keep in mind that in most cases, this will be considered by Spring Test as a so-called customization. And if you really need to use mock bins, it could make sense to shift all of them to your parent class or shared integration test configurations. Just be aware about this. Next optimization is related to databases. Instead of creating new test container for each Spring context, it could make sense to reuse some statically cached Docker container. Just keep in mind that it will require more careful cleanup policies. So for example, your tests that can conflict to each other using fixed IDs can conflict more. So you can introduce truncating listeners that will clean up or flash all the data. So let's consider a sample configuration for such bin. So this is classic singleton. So you can see that this is synchronized method that is initializing the container not more than once. And we expose it in a bin method of test configuration. So things that I would like to emphasize here. we intentionally override destroy method. What it means? When we create Spring context with Docker container exposed there, when later when the Spring context will be shut down, it will close all the bins using close or destroy methods. We don't want this because we want to reuse this container till the end of our JVM. Instead, it will be closed by the shutdown hook or so-called rook daemon, which is a helper utility of test containers to close leftover containers. Okay, next optimization is also related to databases. Probably if you are using relational databases in your integration tests, you're using some kind of schema utility, for example, Flyway, and instead of applying schema each time you run the test, you can pre-create your Docker images and store them on your Artifactory or local registry. Just use some calculation mechanism for tag that can be, for example, the hash sum of your migrations. This can boost your integration tests significantly. You can find instruction in internet, or I think ChatGPT can help you with it. Okay. Next, optimization again relates to databases. If you are using a single database, which is pretty classic in microservices, it could be not a big, it could be not much sense for you. But in a monolith application, we have a lot of databases, and we have a lot of databases and schemas working simultaneously. I think all about 10, or even it can be the same schema, but for example, sharded if you are testing your sharding mechanism. So instead of initializing eagerly your Docker containers for Postgres and data sources, wrapping those containers, you can use lazy initialization. So let me show you. Okay, don't worry again if you don't see it in details. I can just emphasize the key things here. Usually how it works. We have a definition of some Postgres container that we start, and then we create, for example, Hikari data source that takes from the container the URL, the credentials, the port, and the data source wraps the container that is eagerly created on Spring context initialization. Instead, we are using Spring delegating data source and expose it as a bin. And it has a callback which will start our Docker container on demand. What does it mean? On the very first call of data source get connection, it will check. If the container is not started, it will start. And we have some synchronization block with like suppliers memoirs. It's just a way to ensure the callback is called not more than once. And it makes a lot of sense in our case at Mira. Okay, next optimization is related to using dynamic ports. If you're writing microservice, probably your integration tests are making some I/O requests, and it could make sense to use random port instead of defined port. Using defined port can look pretty convenient because it's like similar to what you have in production. Using random port will also require to use annotations like local server port to obtain the real port in your tests. Or if you manually create server socket, you should use port 0 that will choose the first available port on your system. This will allow you to have the parallelism of running your tests. This can be tests from the same module, or you can run more modules in parallel, but if your intention is to boost the speed of your integration test suites, this can have a very positive effect. The same for test containers, Docker containers. You should not rely on fixed ports. Always use dynamic ports. This is a popular advice for test containers best practices. Okay, let's talk about few bad practices that have negative performance impacts. So let's consider some test configuration that creates a data source beyond the Postgres container. The problem here is that we have only one bin, which is like Hikari data source. And the problem with this definition is that when Spring will shut down our Spring context, it will close the data source as a bin. So it will revoke all connections, but this is not enough because we will have dangling container that will stay there until the end of JVM lifetime. And again, at scale, it can be a huge problem. I mean, for sure, this is for scenario when you're using not static container, when you intentionally want to close it with a Spring context. So the fix is pretty easy. You should just separately declare the Postgres container and data source, and Spring will initialize it in the proper order on the bootstrap of your Spring context, and the opposite order will happen when the Spring will close the context. Another popular problem is not managing correctly the life cycle of bins that start thread pools. So for example, this is a sample service, and as you can see, it creates scheduled thread pool. Everything is fine until Spring shuts down the context. The problem is that the thread pool will stay alive. On a small scale, it can be not that visible, but on a bigger scale, it can lead to issues. For example, you can have mixed logs. So when you analyze log of some test that is more close to the end of your suite, you can see warnings of tasks scheduled in the very beginning, just because this is the same static space and threads just stay alive. It's pretty easy to fix this. Just add missing predestroy methods that will shut down your executors. Okay, so this is more or less standard advices which you can find. But in our case, it was not enough. So we had to revisit standard behavior to make it more efficient. Let's get back to our test suite of 8 tests. So, first of all, what we can see, if we know from the beginning the order of our tests, and we can pre-calculate the configurations, which is quite cheap operation, we are aware that from, after executing some particular test, we don't need to keep the context in the cache anymore, and we can automate this. So for example, test 3 will create its own context, but it's not used by any other subsequent test, so we can close it eagerly in some automated way. So the same for test 4. We can create the context for this and close immediately, but not for the very first context, because it's still used in test 7. So you can see that the average number of Spring contexts which is active is already way better. Can we do better than this? Yes, we can do better in case if we change the order of test execution. So all tests that use the same configuration can go subsequently one after each. So in this case, we'll have best possible combination. We'll have not more than one active Spring context. We will not initialize Spring context more than once for the same configuration. So how we can implement this? So actually we need to do two things. We need to reorder tests and implement some logic that will do smart context auto-closing. That will be a replacement for standard dirty context annotation. So the problem here that the Spring, on the level of its framework, doesn't have access to the order of the tests. It just executes tests that are requested from test engine like TestNG and GUnit. So this means that actually we need to do this on the level of test engine, like TestNG, GUnit, and it's even possible for GUnit 4 if we use GUnit Vintage on GUnit 5 platform. You can find the implementation QR code at the end of this presentation as well. I just don't want to bother you with the source code. In few words, in GUnit repeater there is an interface that is called class orderer, which you need to implement and define the implementation in GUnit platform properties, and it will be auto-discovered. For TestNG, pretty similar. You need to implement two interfaces and put the SPI definition for this. So how this implementation will look like? It has a list of integration test classes as input. Then it uses a Spring Test utility, exactly the same that is used by the Spring Test framework itself when it makes a decision if the cached context can be reused or not. And according to the calculated merged context configuration, we can reorder the test. And then we save the order of the test of those tests because we need it for the second part, the execution listener. So this is the execution listener that will eagerly automatically close Spring context which is not needed anymore. So that's briefly it. So if we know the order of tests in advance before we start the execution, we have a very simple criteria. This test is last for this configuration. We don't need to reuse the context anymore, and we can eagerly close it. Okay, you may be tired with the code. Only pictures next. We had very impressive numbers when we implemented those optimizations. So on this chart, you can see the number of active Docker containers on a local laptop when you try to run the whole test suite of our biggest module with integration test. So after about 25 minutes, it just stuck with out of memory trying to bootstrap new containers and actually fails. So it's just not possible. The only one reason why this did not happen in our CI/CD environment is that we use test distribution. So we didn't have just a machine that tried to run all of them at once. They always tried to execute some slice subset. And now on other charts, you can see different combinations of the advised ways to optimize this. So again, this is reordering of test execution, automatically closing context when it's not needed, and using lazy initialization of our Docker containers for databases. As you can see, the combination of all approaches, the green line, is a better one because we have a very small number of active Docker containers. Also, would like to emphasize, in this scenario, the test execution was the fastest in comparison with any other optimization because our machine was not losing a resource switching the context to manage all those heavyweight Docker containers. Another very interesting outcome of using this way when we reorder integration test and close eagerly the context is not reused, that now we have some kind of serialized way with all integration test execution. I'd like to emphasize that we are talking only about single thread per module. All those cutoffs is actually closing Spring context, and this is a number of active threads. Like you can connect Visual VM to observe this, and what you can see, I mean, what we saw in our monolith test execution when we executed it locally, that there is obvious trend. It means that there is a thread leakage. So the serial execution of integration test with eagerly closing context highlighted this problem, which we had to address. Also, similar, we found out the heap leakage. You should not underestimate optimization of integration test classes, because, for example, if you address issues like this, you can significantly improve the proper, graceful shutdown of your application. Also, in our case, it helped us to discover few production leakages, just optimizing integration tests. So, as a result of this discovery, we created the library, which is like one fit for all. It works in our monolith application. It works in our microservices. The source code of this library is available in GitHub and Maven Central. And it has pretty simple instruction to be used. So just add a dependency, remove most of dirtiest context, especially if you put it on the parent classes of your test suite, and optionally enable info logging. So I'd like to emphasize here that usually you cannot just remove dirtiest context, because those annotations are here for a reason, because your tests are conflicting. But with a library, you can do it. So if you run test suite with a library, it can give you some valuable insights. So for example, just a test suite, you can see, like in this case, certain test classes will have 6 groups with different configurations. You can have insights how many different configurations you will have, and it's printed in the very beginning. And again, the library doesn't give you any overhead, because Spring calculates the same merged context configuration object when it executes the tests. So you can have like a reasonable question. What does it make sense like for small projects? And the answer is yes, especially if you have a lot of small projects, small microservices that, for example, share the same CI/CD environment, and you use heavyweight beans, because the average load on your system will be reduced. Also, we had pretty successful adoption in some of our microservices by simply adding this library and removing existing dirtiest context annotation, like build time reduced from 6 minutes to 3 minutes. So the effect in some scenarios was about 30%. Even in case if you add the library and see that build time is still the same, I would say that's great. Probably there was no dirtiest context usages, but you still can consider this as helpful, because again, you will have less containers and thread pools and open pores in average, and this will work in the long term. So we use this solution for years so far, and it works quite well. For sure, I tried to submit this as a part of the Spring framework, and there is an issue, and I even got some feedback from Sam Brannan. It was quite positive. At some moment it was added to 7.0 milestone, but for now, unfortunately, 7 milestone was removed from this issue. Let me repeat one more time. The problem here is that Spring cannot control the order of unit test execution, so it should be done like on a higher level. Maybe this can be a part as Spring Boot. I don't know. I'd like to attract attention to this issue. Maybe you can vote for this. Also, there are very huge topics and they're out of this discussion, but I have to mention this if we're talking about optimizing integration tests in general. So the most crucial factors to optimize your integration test is local and remote build caches, test distribution, and predictive test selection. But you need to combine different practices because everything that we were talking before was optimizing like the worst case when you need to run all test suites. And I would like to summarize this. Try to reuse your contacts, maybe share it, maybe not. Initialize late and release eagerly. And if you're working at big scale, be ready to revisit standard behavior. Also, I'd like to appreciate the huge work that Spring Boot team did to simplify things and hide the complexity. But if you work at scale, you need to understand how it works under the hood and go a bit backwards to change the standard behavior because it doesn't scale well on a very big projects. And the last, I strongly encourage you to write integration tests because integration testing is one of the major factor of real code quality in your projects, especially if you use technologies like test containers that can properly simulate more or less close to production environments. And just keep in mind that it's easier to optimize existing integration tests than to write integration tests from scratch. So invest in it. The library is available. Presentation slides is available. Thank you very much. Happy to be here.